Myself, Dr. Rajendra Prasad. I'm working as professor and head of the cybersecurity department. Today, I'm going to give the lecture on the structure of compiler. Previously, we have seen some what are the phases of the compiler is. We have seen totally for 7 number of phases. These 7 number of phases that can be divided into total for 2 parts, which are analysis part and also synthesis part. Means whatever phases is of the compiler you learned previously. So those phases that can be divided into total for the 2 parts only. So majorly we can define these 2 parts are called as analysis part and also synthesis part. Come to the analysis part. What is the analysis part? What we have? So the analysis part consists of total for 4 phases from lexical analyzer phase to intermediate code generation. Means so the lexical analyzer phase is one of the first phase for defining the tokens. For defining the tokens as the output of source program language statement. Then you come to the syntax analyzer. You know very well about syntax analyzer. The basic idea is it can arrange the derived tokens from the lexical analyzer into according to some syntactic structure. Here you may use the parse tree or syntax tree. The third phase is you want to verify with semantic inconsistency or semantic consistency. If any semantic inconsistency is there, then we will show the errors. That is the idea of semantic analysis. Another one is intermediate code generation. So the duty of the intermediate code generation is the code becomes small. Means even you are giving you are typing in source language very bigger statement. So converting bigger statement into target code, then what happens is I think the system will be slower for running of the corresponding program execution. That's why we want to convert the code into some other format is intermediate code form. After that, the intermediate code that can be converted into target code. So totally we have to take in we are taking totally for 4 phases in the analysis part. These phases are lexical analyzer phase, syntax analyzer phase, semantic analyzer phase, and the intermediate code generation. Here we give the what are the working scenario of each and every phase that comes explanation about the analysis part. So here I am giving the idea of the analysis part. Our aim of the analysis part is dividing source language statements into individual lexemes. Nothing but so that can be performed by the lexical analyzer. Lexical analyzer it scans each and every character and recognize the tokens with the input buffer. So what is the input buffer? We will explain in coming slides. Therefore, the input buffer, the lexical analyzer recognize the tokens by finding some group of the corresponding characters. So the basic idea is dividing the source language statement into individual lexemes. That is the idea of lexical analyzer. And after that, we use the syntax analyzer that imposes the grammatical structure of obtained tokens or lexemes from the lexical analyzer. So here the first part is lexical analyzer duty. Means lexical analyzer it scans each and every character so that it identify what are the tokens or what are the lexemes that should be identified from the output of the source language statement. Initially, you are giving the source language statement that can be divided into some number of tokens or number of lexemes. This is the basic idea of lexical analyzer. Second is after applying the tokens from the lexical analyzer, we should arrange all tokens according to the subgrammatical structure. So that is the idea of syntax analyzer. Means if any syntax things are missing or any typographical things are missing, then with the help of the syntax analyzer, so the compiler will verify all kinds of errors and report to the user. So syntax analysis aim is to identify the syntax errors. That is the idea of syntax analyzer. The third one is suppose there are no errors in the syntax analyzer, then output is generated. The output is in the form of syntactic structure of the various tokens. Means whatever tokens are received from the source language statement that can be arranged in the form of the syntax structure. So that is received as output of syntax analyzer. After that, we can verify the meaningless. Means what is the what the meaningful sentence is. Suppose we have no incompatibility between the data types of the items, then that is called as a meaningful statement. Suppose you are unable to do the processing of any arithmetic statement, so with help of some incompatible data items, then it shows the thing is some semantic error is there. So semantic nothing but you are verifying that whether the given sentence is a meaningful sentence or not. Sometimes you are not getting the meaningful. What case is example is suppose I want to add one number and also one character. It is not possible. Addition of two numbers, addition of two integers, addition of two floats is okay. But addition of integer and float, in that case some type conversion is needed. Suppose you are missing the type conversion and you are missing the some after a decimal point, there are some values are there. You are missing that result when you are adding the any two numbers. So you regard to the data types. Any incompatible data types are there. So sometimes the type conversion statements are required into float or float to int. That kind of schedule you are using the programming language statement. So that idea you are getting which phase nothing but semantic analysis means you are obtaining the output from the syntax analysis some syntactic structure of the program language statement. So syntactically it is correct, but what if the semantic is? Means you are making any semantic inconsistency or not. There is no semantic inconsistency, then you have to proceed for the next phase. Means up to now we are verifying the syntax errors and also semantic errors with the help of two analyzers, syntax analyzer as well as semantic analyzer. Then you are coming to the intermediate code generation. So what is the basic idea of intermediate code generation? Why you are applying the intermediate code generation? When you converting the code into target code, because of as per the compiler definition, the source code that can be converted into the some mission code or target code. So, but mission is understanding it, mission language code, but sometimes the very big mission statements are there. For making the execution of that code is, I think it will take some time. So, for reducing the runtime point of view, you may use some kind of idea is intermediate code generation. So, this is the fourth phase. You are assuming the phase of company. So, that is the happen when organized the grammatical structure of lexims is then converted into the intermediate code generation. So these are the totally four important. So this analysis part consists of totally four phases: lexical analysis phase, syntax analysis phase, semantic analysis phase, and intermediate code generation. Along with these four phases, analysis part is also interacting with one special kind of data structure that is called as symbol table. So symbol table it records the information of various fields. So it means whatever statements are given, they have some functions and also operands. So operands nothing but it also recognize one token, or they are also called as lexims. So lexims are tokens, their values that can be stored in special kind of data structure that is called as a symbol table. So finally, you know that analysis part it consists of four phases: lexical analysis phase two, intermediate code generation, and also interacting with the symbol table. So here I'm asking a very simple question is what are the phases of analysis part? So here you identify the first phase is called as lexical analysis phase. The second one is syntax analysis phase. And third one is semantic analysis phase. And the fourth one is intermediate code generation. Intermediate code generation. These four phases are collectively called as analysis part of compiler. So this compiler means the compiler structure it has the analysis part, analysis this part. Analysis part has total of four phases plus one special kind of data structure that's called as a symbol table. So what the purpose of symbol table is the arguments or arguments values that can be stored in this symbol table. So during the execution of the program, so you want to access the data. So the data is available in the symbol table in the form of the records only. So by the entries of the records, you can easily access the values of arguments or values of arguments. So these are happening in case of analysis part. Next, we come to the synthesis part. What do you know synthesis part? So after the analysis part, what are the remaining phases are pending is total but two phases: code generation and code optimization. So what is the basic idea of code optimization? So optimizing the code, so using the user ideas means every user has it has its own ideas. So their ideas are implemented because of for reducing the complexity of the code in terms of saving the memory and as well as improving the fastness of the code. Respect to that, you may apply the code optimization. Once it is completed, then you come to the code generation. So code generation part is so how the program that will be translated to the target code. Target code that can be understandable by the machine. So between that, you take the output is from intermediate code generation. That intermediate code generation that should be sometimes optimized by the user. User if the user is interested. See hence code optimization that comes for the optional phase. It's called as optional phase. Means the user may or may not be attempted his code optimization. So he wants to willing to reduce the complexity of the code, then he may apply some code optimization techniques so that we are getting the two benefits: saving the memory, saving the main memory, as well as improving the fastness of the code. We have to observe with these two things as the code optimization. Next, come to the thing is code generation. What is the code generation is? So code generation is the code that will be translated. Which code is? So previously the analysis part we obtained the final format of the code is the form of intermediate code. That intermediate code that can be converted to the target code. So that is the idea of code generation. Means in the code generation, the code totally that can be converted to the mission understandable code. Mission understandable code. That's called as code generation. So these two phases are comes under the synthesis part. Under the synthesis part. So synthesis part it has totally for two phases. What are the phases? Nothing but code generation and also code optimization. But as per the sequence, you are getting the you attempt the code optimization is first. That is the optional. User wants to wish the code optimization. He may use the some different types of code optimization techniques, and then he go for the code generation. This is a sequence you should follow in this part. Code optimization, then you can apply the code generation. So here again, I am asking some simple questions. What is the front end of the component? So based upon this class idea, so finally you can recognize. So what is the front end of the computer is? So always the analysis part. Analysis part it becomes the front end of the computer. Here I am writing what is front end of the computer. What do you identify? What are the phases you identify on the analysis part? In the analysis part that comes the front end of the computer. Next come to the back end of the computer. What are the backend is? In the backend, we find mainly code generation. Code generation. And as well as into the optional phase is code optimization phase. Code optimization phase. So these two are code optimization and the code optimization. These two are comes at the backend of the compiler. Analysis part means the total four phases of the analysis part that comes front end of the compiler. So finally, I want to show what is the entire structure of the compiler. This structure that can be divided into whatever two parts up to this. The exit analyzer 2 intermediate code generation is a part 1. That part is called as analysis part, and another one is synthesis part. The synthesis part includes code optimization. It may be for machine dependent code optimization. You'll get in the ideas in the coming classes what the machine dependent code optimization is, and code generator, and also code generator. So these three are comes under the synthesis part. So you can say that what is the structure of the compiler is. Structure of the compiler, it has analysis part, you can explain it. Explaining the analysis part, what is the lexical analyzer, what is the syntax analyzer, what is the semantic analyzer, what is the basic item code, integrated code generation. You must explain the analysis part. This is the first part of the structure of the compiler. In the structure of the compiler, what is the second part is synthesis part. After that, you are able to explain what the third one is symbol table. So means you must explain the analysis part, what is the synthesis part, what are the phases of synthesis part, what are the roles of individual phases of the synthesis part, as well as what is the idea of the symbol table. So you must explain totally. These are the three components. You should identify how many components? Three components. Analysis part, synthesis part, and plus also symbol table. This totally called as structure. The topic is structure of a compiler. Structure of a compiler. So it means the structure of compiler, you must explain totally for how many phases. Here totally for 4 phases. Here 3 phases, and plus one symbol. 7 phases you should identify the structure of the compiler, and one special kind of data structure for storing the information. For that purpose, we must explain this symbol table. So, with the example, already highlighted this example in previous classes, how the statement that can be converted into total for the tokens, individual tokens, means this total for individual source program language statement. This source program language statement that can be converted into some individual tokens. These are the individual tokens. This is the identifier one. This is the second identifier. This is the third identifier. This is the constant value. And operators, this is the operators. You may have the operators. Operators remain same. Like that, you can recognize how many number of individual exams or tokens are 1, 2, 3, 4, 5, 6, and 7. So in this particular statement, 7 tokens, 7 legends are identified by the lexical analyzer. How it identifies the tokens? Because of here so many characters are there. So for example, the position of the characters are P, O, S, like that. Many characters are there. But here grouping the characters, how you group the characters, how you can separate the equals, that will be I will explain in coming slides. So, but here up to now you are getting knowledge lexical analyzer, but takes the input is source language statement and find the output is and individual tokens. So this called as the lexical analyzer. After getting these tokens, these are arranged according to the some syntax structure. Here I am following the syntax structure is tree like tree. I am saying the tree. Tree like intermediate code generation. So this also called as past tree. This also called as parser tree. So this kind of idea is called as means you convert the individual identified the lexical analyzer into some conversion of past tree or syntax tree. So next we come to that the meaning. What is the meaning of the particular statement? If any inconsistency is there, suppose I am assuming these are the floor pairs. These are the floor pairs. Here it is not a floor pair. So according to the meaning of the sentence, okay, it must be the 60 also must be in the form of floor. So here I am using the type conversion. After that it becomes 60.0. Now all are floor pairs. So semantic consistency point of view, no issue. So that can be done by the semantic analyzer. So this is a symbol table. So you want to the first identifier value, you get that value from this symbol table. And one more thing is intermediate code generation. What happens to the symbol? Suppose sometimes we have some very big arithmetic statement, very big assembling statement, many operations are in. So with that, I think we are getting the some complexity from one-time point of view or memory point of view also during the conversion of the source program to the complete program. So the better idea is to try to reduce the number of operands in the given statement. So it means the bigger statements of the source language, so that can be converted into some simpler forms of the statement. So maximum you are allowing the three operands. So this is the idea of the internet code generation. Means the previous statement, what you received, the statement that can be converted into three underscore statement, it becomes simpler. Then when you go in for generating the mission code of these statements, the length of the mission code is also very simple. So the mission is can easily execute in a faster way. There is a benefit of internet code generator. So after that, you may apply the optimization means based upon the user ideas, the user logics. Sometimes the code complexity may be reduced. Now, number of lines of code using these two lines also we get the same. So code is optimized. Means when execute the four results, you can observe the result. So and after execution of these two statements, we also will get the same answer. So but the code is reduced from 4 to 2 lines. 4 to 2 lines means the number of lines of source code is reduced. That is the idea of code optimization. So it means based upon the user idea, sometimes user may attempt this phase or may not be attempting this phase. So always code optimizer phase is called as optional phase. So after that, it can be converted into some equivalent to mission code, but not directly equivalent to mission code. So low-level language is called as assembly level language because of using the assembly level language, directly how it interacting with the registers, the data is stored into the registers. So after getting this assembly language code by the assembler, we try to convert into the object code or mission code. So that is the idea of code generator. So now we have the complete idea of structure of compiler. Here we have discussed the 3 points: syntax, lexical analyzer to intermediate code generation. That's a part of analysis part, and synthesis part, which have total for 2 phases: optional code optimization as well as code generation. And along with to maintain a special kind of infrastructure that is also called as a symbol table. The relevant example also explained. So this is the idea of the structure of a compiler. So after that, we have to know some terminologies in the compiler. What are the phases? What are the phases? Already you know aware about the phases. And what are the passes? Pass is a neutral. So here I want to make a group of some number of phases. That is called as single pass. The phases deals with the local organization of a compiler. In the implementation, activities from the several phases may be grouped together in a pass. So the front-end phase of compiler are lexical analyzer, syntax analysis, semantic analysis, and intermediate code generation. Grouped as a pass. Here, the totally for these 4 phases, lexical analyzer to intermediate code generation, that can be defined as a single pass. Some other pass is optimization, but you are not always applying the code optimization based upon the user interest only. You can apply the code optimization. So that's why this is called as the optional pass. One pass is the first pass is 4 phases. You make a group of 4 phases. Lexical analyzer phase to intermediate code generation. That's the one single pass. One more different pass is code optimization is called as optional pass. Last 2 passes remaining ideas code generation. Therefore, the code generation we have to maintain some other kind of passes called as backend pass. Finally, you are knowing that you have to make a group of activities from several phases. That is called as pass. You should identify totally for how many distinguished passes. Totally for 3 distinguished passes. One pass is called as front-end pass, which have the comprising the activities from lexical analyzer to intermediate code generation. The next pass is optional pass, is called as code optimization. If you apply the code optimization, that comes under another pass. One more pass is background pass, which is consisting of code generation used for So you have to see that some real-time example what really happening in the face of structure of compilers. So this is the pseudocode you have to take in the. It may have the many number of variables like integer and float variables, and we have bigger statements. You have to see that how many number of operands are 1, 2, 3, and 4, 5, 6. 6 operands are there. So you want to convert this entire code to target code, target code. So you are getting the bigger machine equivalent codes are you getting, and you are making the education also. You are spending more time. That's why we don't go for directly convert this code to target code. Before that, you must use some intermediate code generation. Intermediate code generation, it uses three address code. I write short name TS, three address code. So you have to see like this code that can be converted into three address code. For example, you are taking this statement. Okay, I'm skipping the do statement. I'm using the instead of do for your understanding purpose. Both I'm using, of course, is unstructured statement, but no issue because I want to explain how the code that will be converted into the some intermediate code generation. So here I could type this one. The count number of operators are maximum is 3. Maximum is 3. Here you count how many number of operators 1, 2, 3. Here also maximum is 3. See any statement. Suppose I'm picking this statement 1, 2, 3. So it means any statement maximum is you are allowing three arguments only. Means less than equal to three arguments. The meaning is you are using the three address code instruction. Three address code instruction. So it means it is a part of intermediate code generation. In the intermediate code generation, I'm using the technique is three address code instruction. So it means the source language, of course, it has more than three operands also that will be converted to some simple statements. These simple statements are having maximum number of operands it allows 3. So you have to see that the previous code, okay, here very big statements are there. The many number of operands are there that can be converted to some simple statements. This is equivalent to the previous code. This is equivalent to previous code. Here anywhere you can check verify that. So any statement can verify that all statements are simple statements because of maximum it allows three operands. Maximum it allows three operands. So mostly case you are using only for three operands only. Sometimes two operands, one operand also allowed, but not more than three operands. So that is the idea of intermediate code generation. So using intermediate code generation, this code that can be converted into some intermediate code format. This is intermediate code format. Then you are trying to convert into some target code. Now you can apply the target code. Then in the target code, each and every statement also is simple statement. And making the execution is very easy. So you are getting the execution in a fast manner, and it requires I think minimum amount of main memory. So you can use the memories efficiently as well as you can improve the fastness of the program. These are the benefits you are getting when you converting the code into intermediate code. So totally this format of the code is called as intermediate code form. Intermediate code form. So previously given the source code, this is given by the user. When you converting the source code into, I think you are applying as per lexical conversion phase, syntax conversion phase, semantic conversion phase. Last fourth one is intermediate code generation. After intermediate code generation, this code is I think very simple form. It allows intermediate code generation. It allows maximum 3 operands only. Because the reason is you are applying the 3 underscore instruction. 3 underscore instruction. It may for tables, quadruples, inner tables. I will explain that in the coming modules. So what is the idea of the 3 underscore instructions? So here we come to a very important part in today's class, that is input buffering and recognition of the tokens. So because your common doubt is how the lexical analyzer will convert the source language into tokens. Because of the source language, I think we are able to identify some separate characters only. So we don't know idea about I think printf is a separate statement. Okay, you have the idea because you are in the language. But initially, the company doesn't know that these are separate keywords and these are separate identifiers. Not have any idea. So that case, you make use of the kind of concept is called as input buffering. So you have to see previously your getting the idea is very simple. So what the lazy compiler is, it scans the characters of the source code and it scans every character at a time and to discover the tokens. But here the challenging task is discovering token is challenging task. It can be implemented by taking the two different pointers. One pointer is called as bringing of the token, another point is look ahead of the pointer. So we see in many cases that the compiler reads one character at a time, but it is a very slow process, inefficient process. So that's why we have to use the concept is input buffering. Use the input buffering. The compiler recognizes some large chunks, nothing but lexemes it should identify at a time, not for the single character at a time. To identify the lexemes at a time, so that you can improve the performance and reduce the work. This is the benefit you are getting in the case of input the buffer. So here we are taking the particular two important pointers. Beginning pointer is a short name is BPTR. You are taking the short name as beginning pointer is, and one more is look ahead pointer is called as LPTR. Beginning pointer, what the beginning pointer is? I think where you the starting, where I think the starting position is the starting position of the string is that should be identified by the beginning pointer. And look ahead pointer is it moves to search when the I think the particular token will be ended for the ending position. So how can you recognize the ending position of the token? That you are getting the any white space. I think you know an area of white space in commas and semicolons. Like that, in separators you are getting okay. With that, the compiler easily recognize that this particular often know this some separate token, separate word, or separate legs. So with that idea, I think it will recognize as the tokens. Until that, it will scans each character at a time, and the font is used in this like 1, 2, 3, 4 positions are there, moves like this, moves like this, moves like this, moves like this. 5, 6 here, white space is occurred. So now this group of first four characters has one token, one token. So it is a logic issue we are using in the case of input buffer. So we have to see the corresponding example. Suppose I'm taking the input buffering like this. This is a buffer, some part of the memory. Okay, you can say that there's input buffering. Here I write like this in, and I maintain here white space. I maintain the white space, and after that again I and J. Sorry, I and J is the comma. It's a comma and J. So here white space is there, the comma is there. Okay. Now you group the int as one token, you recognize one token. How it will recognize token? Because after that one separator is came. One separator is came. The separator is here white space. After that I, okay, clear the character. After I, here comma is happened. So comma is happening by you recognize this token for one another token. Another token. And J, after J, semicolon is there, is also separated. Okay. Now J is also another token. Like that, int is one token. After some white space is occurred, I is another token. Again, comma is occurred. So J is another token. So this is the basic idea of for recognize the individual tokens. So input buffering. Here we have to send the source language statement, maybe in the some part of the memory, and initial forward pointer. I think we have to see that the previous slide 2 pointers we are using begin pointer. So initial the begin pointer is at I only, and you have to move another pointer, look ahead pointer, move this position, move this position. Here we get in the white space. Okay, now we have terminate the look ahead pointer position. Now we have to read for how many characters? 3 characters int. You make you group them these 3 characters. Then we know that the int is for one particular token. So it is the process for identifying the tokens. So this topic is input buffering and also recognize the tokens. It is a very important role of the lexicon and lexicon. So with this today we are finishing. The topic is the structure of a compiler. So here I am taking these are the 2 references. One is the compilers principles, techniques and tools. This is one of the textbook. From that we have referred the content as well as another website also given for this also. So we have taken some important ideas. Okay, these two references we have considered the key reference of this class. Now, it is, thank you.
Like, share and subscribe. Hit the bell icon for more updates.